So I'm really excited to bring on Colin today. I think generally it's my opinion that coding agents has been like the clearest proving grounds for any of these like long running tool-rich agentic systems. And they're like the first ones that really drive a lot of economic value. So I'm really excited to start this little speaker series on autonomous coding agents. And my goal, for me at least, is to try to bring back as much learnings as possible from these coding agents into more general purpose RAG systems. Today's guest, Colin, was previously a founding engineer at a company called Augment, which open sourced the top ranked SWE agent and has helped build a lot of Augment state-of-the-art tool suites. He's also co-authored Meta's science paper, Cicero, which was the first diplomacy AI to reach human parity, and knows a lot about agents. And in the next 30 minutes, he's going to share with us what he's learned about building these state-of-the-art systems, specifically on SWE-Bench. And by the end, I hope we can bring a couple more things to the verticals that we build on. We'll have questions at the end. If you share the Slido in the chat, you can basically ask your questions there, upvote them. And with that, Colin, take it away.
So the topic we're going to talk about is this question: do agents make RAG obsolete? And here I really mean RAG in quotes. And so RAG is this kind of traditional idea we have that's evolved over the past couple of years. Of you have this embedding database with Pinecone or insert any other tool, Turbo Puffer, and then you do some dot products, and then you get all these relevant documents and you put them in your prompts. Does agents make all that obsolete? And we're going to use my experience building an agent for SWE-Bench Verified as our case study. SWE-Bench Verified, for those that aren't particular, is the canonical AI coding evaluation. We'll get into a little bit more what that is as a refresher. Okay, AI coding. Let's take a kind of zoom out and think about what's been going on in the space for the past couple of years. 2023 was completion models. So this is like GitHub Copilot. 2024 was when people started using chatbots to help write code. This is in particular when like people found that Claude was really helpful when it could like look at your code base or look at files. 2025 is really about agents. Now, if we look under the hood and think about the underlying retrieval tasks that are relevant to each of these products, the retrieval complexity is only getting higher. So for completions, the desiderata for a retrieval system is, okay, it needs to be super low latency. So that's hard. But the retrieval is not super difficult for code, at least. So I'm trying to complete a function. Let's say it's a implementation of a method that lives on an interface. I probably want to go retrieve other implementations of that interface for inspiration. And so you just need to like copy word, like look for like other locations where that function name is present. And that's clearly not that hard of a retrieval task. The only thing that's annoying is how latency sensitive it is. Then we go to chatbots in 2024. And with chatbots, things are getting a little bit harder. Okay, let's say I'm building kind of like an LLM power application. I may have a question for my chatbot, like, how do I abstract away the LLM SDK that I'm using from my application? So what that means is maybe I want to use OpenAI models. Sometimes I want to use Gemini models. And I want to have one consistent API for all these and not have to use the Gemini SDK sometimes and the OpenAI SDK and other times. And so that probably means creating some kind of interface on top of the OpenAI client and on top of the Gemini client. And then the question is, find the locations of the Gemini SDK and the OpenAI SDK in your code base. Then can I figure out, okay, how do I abstract these? And can I figure out maybe where should I put that abstraction? And this is a bit more of a challenging retrieval problem. And so here was when we really found like training embedding models becomes a little bit more important. Now with agents, it's getting a lot more complicated. Now the agent has to understand many different parts of your code base. It has to look through different files. It say looks through 100K tokens worth of files, and then it needs to truncate those from the prompt and go look at another 100K worth of tokens. So things are only getting more complicated. A quick refresher on what exactly do you mean by retrieval here? Everyone thinks about embedding models, but there's really a lot of different techniques that could be used. There's good old BM25, which by the way, for completions, we found was extremely good. There's embedding models, which have a little bit more flexibility, are good for less structured content, are good when you're not doing just similarity, but you're doing some kind of more complex mapping you're trying to model in the retrieval. And then there's like other tools like grep and PageRank. As I mentioned, we were making this agent that could perform on this eval called a SWE-Bench. So SWE-Bench is essentially like I give the agent a description of a coding problem, It has access to a code base. There are some held out tests and some not held out tests. And then the agent has to go implement that PR description in that code base. And then we run all the tests at the end and see if it passes. It's able to do things like, use whatever tools we provide it, whether it's iterating through files or running tests. So we created this kind of open source repo for this, and it has all this simple stuff you may need. It has a bash tool, file viewing tools. It has this notion of a sequential thinking tool, and then everything else like Docker harnesses so that the agent can run code and so forth. Now we ended up getting to the top of this eval. So you see that's us there up top, Augment Agent v0. One of the most interesting facts about this work was that we explored adding various embedding-based retrieval tools, but found that for SWE-Bench tasks, this was not the bottleneck. Grep and find were sufficient. So this is really interesting. And frankly, the first time that I saw this result, I was like surprised. I thought maybe there's like a bug in our evals or something, because like clearly embedding models should be so much more powerful than grep and find. And yeah, so I dig a little bit deeper. And so we'll look at some examples and try to figure out, does this data point indicate that traditional RAG as we know it is obsolete? So here we're looking at a very specific SWE-Bench problem. So I'm just going to read through it so we can get some context. So this is pulled from an actual PR on GitHub, or an actual issue on GitHub. Modeling separability matrix does not compute separability correctly for nested compound models. Consider the following model, and there's some code. Its separability matrix, as you might expect, is diagonal. If I make the model more complex, and then the user starts talking about how in a particular situation, these inputs, outputs are no longer separable. And it's not really important here, what is the separability matrix, but just it's good to get a sense of what is the problem. So there's this code base called Astropy. There's this function called separability matrix in this file, and there's some property of it that seems buggy. So now let's look at what the agent does to try to solve this problem. So here I actually took all of our agent's tool calls and LLM responses and just pasted them here. We can click through these and get a sense of what it's doing under the hood. So first, we have this initial prompt, which obviously contains all of this, and we ask the agent to figure out how to fix it. Then the agent responds, I'll help you implement the necessary changes to fix the issue with the separability matrix function for nested compound models. Let's start by exploring the repository structure to get familiar with it. Then it calls the bash tool using find, and it looks for all files that have the prefix in the name separab. So it's like separability, separable. And then it finds this separable.py file, and then it uses a file reading tool to look at that file. And then it says, now let's also look at the compound model class to understand how it's structured. It looks in this file core.py, and it greps for the word modeling, then doesn't quite find anything. So now it uses a file reading tool, and it reads lines 1 to 50 for core.py. You'll notice here, it's just reading 50 lines instead of reading all the file, which it did for separable.py. One, because this is an option, it can optionally just look at a few lines, but also this is a much larger file. And so let's look at the compound model class. It does a grep. It still doesn't find what it's looking for. It does another file read. Still doesn't find what it's looking for and does another grep. Still doesn't find what it's, actually it finds it then. And then now it's like looking for the function. And so now it does another grep. And then it goes on and it does implement the correct solution. And so my takeaway looking at this was agents are dumb, but they're persistent. So they eventually find their way around with grep and find. In other words, the agent's persistence is compensating for worse tools. So there are some benefits of this agentic retrieval with grep and find. One, iterative retrieval is super easy. If any of you have seen what an old school iterative retrieval setup might look like, it's something like in this bottom. You have a prompt 1, which is your query. You put that in an embedding model. You dot product against the knowledge corpus. You get some top K documents. Now you have a new prompt that's the query plus this top K documents. You put that into a new embedding model, which you've trained differently. You dot product that against the knowledge corpus. You get some new top K documents. And then you have to decide how to balance your resultant prompt between this set of top K documents and this set of top K documents. Prompt token budget management is a lot easier. So this is some code from our code base. And basically what happens is the agent's iteratively doing this crazy, this and grepping all these different files. And anytime we hit our token budget limit, which is, I think it was 150K tokens, we just truncate all the old tool calls. So here we replace all the sequential tool calls with truncated. We run tool if you need to see output, input, output again. And then we do the same for other tools. And if it needs to go look at the output of some old tool call, like some old grep, for example, it can just rerun that grep. So with vector databases, you obviously have this whole new dependency, this whole new database you have to deal with. You have, say, a sync you have to manage with completions. We have, say, like a 50 millisecond service level agreement for how quickly we update the documents on the client. So in that VS Code editor or whatever your editor is and our servers, none of that you have to worry about anymore. And finally, there's this really cool course correction property where if the first call to say the bash tool with find or with grep doesn't work, then it tries again and maybe uses the view tool. And then it tries again, it uses grep. But the challenges with grep and find are they're hard to scale. So imagine doing grep and find against 10 million files. What about 100 million files? You definitely can't replace PageRank on Google with grep and find. And they also don't work particularly well with low structure natural language. So if we look the bottom right here, just some random code snippet I picked out. There are all these high signal words in it. So there's text prompt, text results, token counter, count tokens, and these make it really easy to figure out how to grep things. Like we'll call again that if we go back to this, there's sepra star. Like that works because code is super structured. And that's not necessarily true for like other kinds of content or information you might want to retrieve over. So what's the best of both worlds? You can imagine this agentic loop, but with access to great embedding models as tools. In order to build this, you still build your underlying embedding system per usual, and you just surface it to your agent as a tool, similarly how we surfaced grep and find as tools. So there are going to be some potholes when applying this to other domains. So one of my hypotheses that I haven't really confirmed, but I think may be true, is that Anthropic models are post-trained to be really good at agentic code search specifically, but I'm not sure how well that generalizes to other domains. As I just mentioned, code is a lot of high signal keywords. And also all of this is pretty slow and expensive. So when we are trying to decide then, okay, how do we architect this retrieval system? We may have some RAG. So traditional RAG, we may have this agentic retrieval. The embedding tools are one option. The grep and find tools are other options. There are different axes we can consider, and each of these axes has different weight depending on what you're building. So there's quality, so how good is the file output? There's latency, so the embedding models, as I mentioned, are like 50 millisecond SLA. Agents can take many minutes. Cost, so the agents are agentic retrieval is much more expensive. Reliability, so agentic retrieval has that course correction, but embeddings do not. Their size of index, so grep and find work totally great for small to medium-sized indices, but for truly large indices, it's just too slow. And then there's the effort to build and maintain your retrieval system. Do you have the engineering resources to deal with maintaining some index and updating it and whatnot? So we look at some examples of some different kind of configurations of systems. Traditional retrieval, it's okay quality, it's really fast, it's really cheap. The reliability isn't great because there's no course correction, but it's super scalable and it depends on the effort to build and maintain it. The main factor here is, I think, whether or not you're training your own embedding models. The quality is really great, but it may degrade in certain situations like really large indices, or when you're retrieving or searching over content that's super low structure, where like keyword searches don't work well. It's slow, it's expensive. The reliability is great because agents are persistent and they're course correcting. And this also gets even much better when the agent has access to some kind of signal that it's in the right direction. So for coding tools, the agent has access to being able to run tests. And so if it gets stuck in some direction and it has some hypothesis for the task it's trying to complete, it can spin up an ephemeral file, run some code, see the output, and then use that to inform how it continues to do the code search. The size of the index, it's not that scalable as we talked about, but the effort to build and maintain it is super easy. And then finally, this kind of third option I mentioned, which is the agent plus an embedding-based tool. The quality is great. It's still slow and expensive, but we get everything else. So we get the reliability, persistent course correcting. It now handles large indices and the effort to build and maintain the retrieval system, it's mostly easy because you have less of a need to train embedding models because agent can just be persistent. And now maybe you want to optimize things further and have the agentic loop and also the really good embedding model that can help. So I want to go through a couple like preemptive Q&As, and then we can talk through questions. So one, I already built a retrieval system with custom trained embedding models. Do I check it and build agentic retrieval? It should be clear right now, no, build agentic retrieval on top of it. Just take your existing system and add it as a tool to an agent loop. How do I eval agentic retrieval? End-to-end vibe eval first. So 5 to 10 examples. Then consider quantitative end-to-end eval or eval just of the embedding tool. Note that improving the embedding tool won't necessarily help because the agent is persistent. So I'll give some anecdotes here from our experimentation. So we were like working on an embedding-based tool for SWE-Bench in particular, and we had some evals that we were using to kind of hill climb just on that embedding model. And we improved the embedding model, but we found that the end-to-end result didn't improve because the agent was super persistent. So you always want to start with that end-to-end eval first, and then go from there depending on where the system is struggling. I'd suggest building the dumbest retrieval tools possible, put an agent loop on top, iterate from here on whichever qualities of the system cause the most pain for customers or for you, and follow the previous eval instructions. And then the last question, our last topic, in traditional RAG, I can improve my system by training better embedding models. How do I improve my system with agentic retrieval? So in general, I would just say build better tools. So this is a little anecdote. Agents are getting radically smarter, but even Einstein preferred writing on paper instead of a stone tablet. So yes, these agents are persistent, but you should give them whatever you can give them to improve the odds that they find what they're looking for. So that could mean adding a re-ranker to your embedding tool. One benefit here is you spend less tokens, so it's cheaper. Maybe it's also faster because the agent messes up less. Your precision on that embedding tool is higher. You can try training different embedding models for different tasks. Maybe you have one embedding model that's really good at answering questions about messages in Slack, and another one that's really good at looking over the code base. You can provide these as separate tools. You also want to prompt tune your tool schemas to avoid pitfalls. So for example, if we look at our bash tool, which as we saw previously, our SWE-Bench agent was using to call grep and find and whatnot, we had to prompt tune it a little to tell it like, this is how you use grep, and this is how you use find. And by the way, don't do X and Y regexes because those will be really slow. Yeah, so that's kind of everything. I'll pause now and we can talk through any questions.
This is great. I have a bunch of questions in my mind, but let's go over some of the questions on the Slido. Marion just shared the link back in the chat. So feel free to just go on there, look at the questions you want to ask, upvote the ones you care about. I think the first question in everyone's mind is actually going to be around the frameworks that you use. So how did you decide what tools to build? Did you build the framework yourself? Could you talk a little bit more about that?
Definitely. So I built the framework myself. Let's go all the way back here. I found you need something very simple, and it's very hard to, I looked at some of the existing frameworks out there and they were nice, but I wanted something super simple. Like here, let's see. Can you still see my code base or my screen? Okay, I'm just going to walk you through a few things in this code base just to give you an example. So we have this tools directory. There's this very simple notion of an LLM tool. Okay, let's see. A tool is in a utils common. Utils common.py. Yeah, so there's this very simple abstraction. It's an LLM tool. It has a name, a description, an input tool schema, and there's like a few commands on it. Then you have this notion of a dialogue messages, which is where we keep track of the dialogue history for the agent. This needs to have options to add user prompts and then also agent prompts and tool calls. And then finally, you need some kind of truncation strategy. But once you have those components, you have that dialogue messages object and you have this LLM tool abstraction, then you're like pretty much good to go. Yeah, that's pretty much it. Then you just call the agent in a loop. For at the top level agent, I actually just implement this LLM tool abstraction. And then it just has like separate LLM tools as like the dependencies. So given those are the only things that are necessary, like I didn't really use any frameworks. Yeah.
That makes sense. I think a lot of people, at least the higher level practitioners, have generally leaned on building things yourself just because you want fine control over the prompts and how things are called and whatnot.
It's just so simple too.
Yeah.
Like
It's just
I'm
really,
working on several new projects right now, and because I left Augment recently to experiment on some different projects, and I built several agents, and I literally and for total things totally unrelated to code, and I literally just forked this code base and made a handful of changes, and it like pretty much just works.
all right. So there's going to be a new agent framework that you're going to release sometime in the near future. I'd love for you to comment on that, like one conversation we had earlier, like last month, where it was just, do I give my agent like access of control, command line and have it do everything, or do you build out these specific like search tools like grep, find, and all that? You mentioned it's really changed the distribution of how these things behaved. Could you talk a little bit more about that too?
Yeah, we just give it access to a bash tool, and it can do whatever it wants. And this works because it's super persistent. So like when it messes up or when it like runs the wrong command, then it will figure out how to run the right command and go from there. But yeah, if you already have a good embedding system, I wouldn't throw it away. It's like probably going to be better than bash. Does that kind of answer your question?
Embeddings, and you're probably going to be good to go.
Yes. Okay. So yeah, one interesting thing here is people have talked a lot about tuning your system prompt and tuning your prompts. There's a whole new access to this now with agents, which is like tuning the set of tools. For bash, we could have instead had 10 different subtools. And we actually did start with this, which was like having the file reading tool, the file editing tool, the grep tool, the find tool, and so forth. And then letting the agent call these tools whenever. And it kind of made the code base more complex. It didn't seem like a very fruitful direction, I'd say.
Interesting. It almost feels like a bitter lesson away. A lot of those things is, you know what, turns out if you just give it bash, it'll work today. And maybe in the future, it's just keyboard and mouse inputs. Got it. It's almost like fewer tools, better tools, and use tools that are very generalizable in the hopes that future models will just be able to use them better.
Yeah, exactly.
One question I'm really curious about is what do you feel like we can learn as practitioners, not in code generation, but maybe what does the AI for medical scribes or the AI for like construction documentation or AI for legal, like for lawyers, what can they learn from the things that the coding community has been picking up on?
The main thing is to do agentic retrieval. So that's like where you give the agent access to tools that are like search tools. The simple answer is like whatever you already have, turn those into tools and iterate from there. I think that's a simple thing, which is very unintuitive maybe to some people because they want to go architect some, whenever there's some big technological innovation, they want to go architect some whole new system, train models and whatnot. But it's really just like a layer on top of your existing search tool, existing search system. And it does cost in money and it does cost in latency, but it just makes things better. So I would just start from there. And then there are all these different directions you can go from there, whether it's like realizing that, okay, now this agent is so persistent, I want to give it access to a new kind of embedding model that like, maybe it was really hard to fit into my previous search system. Maybe I discovered that like, actually my embedding models don't help at all. And doing some more basic search or doing like a lean integration or something like that is just as effective and way less total cost of ownership for the team. And so I just go to that and deprecate my embedding service. You need to make those decisions once you get a sense of what's moving the needle on top of the basic agentic retrieval system.
That makes sense. I think cost of ownership is something that people are not really thinking about these days, but really should, especially because in the future, more and more things will be abstracted away. I think maybe last year, everyone was asking me how to fine tune language models, but now very little is going in that direction. But I think a lot more folks are thinking about doing fine tuning embedding models.
That's an interesting topic. I still think no one really knows how to fine tune embedding models. Like very few people do. New technology is, I can't tell you how many people have texted me over the past 2 years because they heard Augment has like really good retrieval. They were like, how do we train good embedding models for insert category X, Y, or Z, whether it's finance or medicine or whatnot, or therapy. It was hard because I was just like, you need to have an AI researcher on your team. And there's not really any APIs for this. There's nothing great out there. But now that it's less important. So I do think this is in some sense democratizing like the really good retrieval systems. Yeah.
Yeah, I think Cursor is the only company I know who's really talked about fine tuning their embedding models. And that's mostly just for the tab model, right? If you look at like the cursor agent, it's not really using embeddings that often in the agent product, but code completion, you really do want like very fast retrieval.
Yeah. So we found fine-tuning embedding models is really important. It really does help. I'll give you some examples, reasons for why it helps. So we talked a little bit about like with code, with completions, but when you're asking these more complicated questions, the embedding model needs to have some understanding of your particular domain. Like it needs to have almost the reasoning capabilities of an LLM. Obviously, it's not going to because it's a much smaller model, but it needs to like approximate that. And like most embedding models that you get off the shelf, that's not really what they're trained to do. They're trained to just look for similarities between text A and text B. So it does really help, but it's a little bit less of a bottleneck now that now they have this agentic retrieval.
Makes sense. This question is pretty interesting because I think it exists in multiple scales, but what are your thoughts on memory and how does it play with other RAG
That's a great
with
question.
coding agents? I know
Yeah,
there's compact as a way of truncation, but we'd love to hear a little bit more about that.
that's a great question. Obviously, memories are super important. Okay, how do you add memories? There's a really simple thing. I don't think this is anyone's secret sauce. You add a tool that saves memories, and then you add a tool that reads memories. Now, how does memories affect how we think about retrieval? Let's look again at this example. If we had memories here that kind of describe something like at the end of this, the model could create a memory that was something like describing some aspects of the code base. These are the files where models are defined. And in general, like models have these kinds of functions on them, or these are the relevant interfaces to consider. When you add this stuff into the memories, it speeds up the next time I go around. The next time I try to do an agent run that kind of has a similar kind of search task as this. So yeah, memories are personalization, but they're also in some way like a semantic cache that speeds up future runs, future code search or future search runs. Yeah,
This is a pretty big question, but can you also talk a little bit more about your eval harness for this SWE-Bench work?
sure.
How does success look like? How do you think about iterating on these things?
Yeah. So
It's really valuable to understand that even as you improve the embedding model, it might not matter because the agent is so persistent. I feel like that's a big learning that
totally.
once you say it.
I wasted a lot of time on this one. And again, this is not to say that embedding models aren't useful as tools. They are very useful, but it's not as simple as if you make score go up on embedding model eval, then score will go up on the end-to-end agentic retrieval eval. And so that's why I recommend to start with the end-to-end vibe eval. I in general just recommend to start with vibe evals. I think this is something very unintuitive to people that come from like classical ML who are always trying to make quantitative evals. Like with natural language stuff, you can learn so much just from looking at a few examples. Once you have a few examples and you have a baseline in your head, like again, it's not a number, but it's like a baseline in your head for how good is the system? What are the general kinds of questions or tasks that it stumbles on? You get to a point where you could look at a problem and you can just tell if the system's going to get this one or not. And okay, once you're to that point, it's like an intuition thing. Once you're to that point, then you try to poke it and you try to test at it. And you're like, what do I think might not work here? And you try to prove out. Can I find some examples that indicate that this particular access of the system doesn't work? Let's say in my end-to-end vibe evaluating thing, I noticed like there are these kinds of questions, which it's both very fast at solving and it consistently solves correctly. And then there's these other set of questions where it sometimes solves them, but it's very slow and it does not at all solve them consistently. Then I focus on those questions and I look at them and I'm like, maybe it's because, oh, our grep tool doesn't ever use this particular kind of regex pattern, or like our embedding models when the agent sends a query to it is never asking this particular kind of question. And I think asking this particular kind of question or doing this certain kind of regex will really help. And then so you add that to your tool schema and maybe it helps. And then in terms of evals for those kind of like more pointed problems, you could do the vibe eval just of that embedding tool of that particular task. And usually that's sufficient. If you already have a quantitative eval lying around, that's nice. I will say once you get to a certain like quality bar with all this vibe evaling stuff of like following different intuitions for what's not working and what's working, you do eventually get to a point where you do need the quantitative eval. So for SWE-Bench, that quantitative eval it's 500 examples, which exists in SWE-Bench. And there's a yes, no at the very end of if not the agent figured the problem out, because you just look at if the test passed or not. You do want that because as you're doing all these kind of like spot check improvements and even the vibe evaling, one improvement may negate other improvements. You need to see how kind of everything nets out. So eventually you do need the quantitative eval once you have saturated all those like early wins, so all those low hanging fruit.
Yeah. I want to call out something that's really refreshing, which is when I talk to you and in the context of RAG, you're always giving very specific examples of queries that we want our system to service. I find that when we're talking to a lot of really smart engineers, but folks who are not as familiar with research, they lead with questions like, which embedding model should I use? Should I use HYDE or should I use Agentic RAG? Versus your example of just what are these specific kinds of examples? What are the failure modes? And just becoming really familiar with the evaluation suite rather than the set of tools at our disposal. I just want to call that out because that's something that's very big in a lot of the consulting work that I do. It always starts with what tool should we use? And then it gets to, we need to be able to handle contact search and scheduling much better. And we need to build specific tools to do that.
Yeah, I'd say one of my controversial takes here is that being a researcher is actually very similar to being a product person. Okay, so what do I mean by this? With both of them, you're working backwards from use cases. You're working backwards from examples. So most AI research these days is not solving a math question on a whiteboard. It's like data. It's like looking at this particular agent run or this particular query and cross-referencing it against other examples and trying to understand like why that query failed or not. And so when you're analyzing this kind of use case level user data or data of your kind of task distribution, that's very similar to being a product person and like looking at and studying how are people using my product and how can I improve it? And so I think there's actually a ton of overlap between product and research, and engineering is like the skill that's like the odd man out. Yeah.
That's pretty interesting. What do you think is missing from these other folks? I think, for example, Klein has talked about not using embedding models in the past and going only for tool use without embeddings. Do you think it's just a matter of there are no good open source code embedding models out there? Is it because we're not training things correctly? Is it because Sonnet 4 is just too good at using grep that we don't need that in the near term?
Yeah, I mean, for SWE-Bench, they're pretty small repos. And so grep and find work great. And so that's how we didn't need to use embedding models for them. But if you want to get to truly huge code bases, or you want to be able to like search over a code base and search over like low structure natural language, like in Slack or in Notion, like grep and find are like less useful. And so maybe it's like you have Glean, that's one thing I mentioned, or as your tool for searching over like Slack or whatever, or maybe you train your own embedding model, but it's not really just grep and find. And then let's say we want to search over third-party code bases, because these models they memorize a good amount of third-party code bases. So they do memorize the OpenAI SDK, but that like random SDK that you found on GitHub that has like barely any stars that you're using, like it probably hasn't memorized that. So you want to be able to search over that. And maybe it has docs. And if it has docs, like, yes, you actually want to search over the code base. The corpus, the size of the index can get really large. And in this situation, grep and find can get slow. And embedding models are really good at moving quickly through these giant corpuses. So that's the main thing I think about is it's like, how much do you want to scale your index? And then what are the different kinds of information that you have in that index? And like grep and find are like going to be less and less efficient. I'll give you another thing that I think we're going to have coding agents search over soon that grep and find are definitely not going to work for. Searching over like video recordings of user sessions. So I have this giant corpus of customer studies. I recorded them all. So I have all these hours of video footage, and I want to search over those when doing an agent call. Like maybe I ask the agent a product question, or maybe I ask the agent, like, I'm thinking of moving this particular button on this web page from this location to this location. It probably needs to search over all those videos. Obviously, grep and find aren't going to be sufficient there. So it's really like about thinking again about your use case and asking yourself, like, okay, if I was a human working on this use case and I was a really persistent human that never got tired, would having this other tool, like this other search tool, help me? And if the answer is yes, then like it's probably going to be useful for the agent.
That makes sense. Do you feel like it's almost an artifact of SWE-Bench being just like too much of a toy set of evals? I think about my time at Facebook where you just can't even grep the code base. We have like custom tools to grep over our code base to understand like who else called this function in the past like 90 days.
Right.
And there's like a special UI because it's like some monorepo, which is luckily it's a monorepo, but in other cases that might be distributed systems and you can't grep any of that.
Yeah, I think that's spot on. SWE-Bench is like one of the most real world of the academic evals, and it's very good. But at the end of the day, it still is an academic eval. So the repos in are all open source, which already biases them to be pretty small and makes them look different from like professional repositories. And the tasks are pretty simple tasks. So there's SWE-Bench and then there's SWE-Bench Verified, which is what we use. So SWE-Bench there's many more examples. A lot of them are like crappy, like low quality. SWE-Bench Verified is like this filtered down version that OpenAI released, where they just filter down to like 500 examples from SWE-Bench. So that's what we worked with. And that's kind of the more useful one. With SWE-Bench Verified, there's some statistic, like I think 90% of the examples took less than an hour for a good engineer to solve. So they're pretty simple examples. And so that simplicity also makes something like grep and find a lot easier. And again, as I mentioned, there's still the latency factor. Like, I don't know about you guys, but I've definitely had these moments where my thumbs are twiddling for 5 minutes because I'm waiting for an agent to run. And that's super annoying. And like right now, we're like, whoa, these tools are so good. They're saving us so much time. But let's roll things forward. And everyone's gets used to the speed at which we're building with agents. That kind of latency is going to get annoying.
Yeah, it's the first time I get Wi-Fi on a plane, I'm amazed. And the second time I get Wi-Fi on a plane, it's like too slow for me and I'm already complaining. So there's about 12 minutes left. We try to end at 4:55 because we have another talk in the hour. One question I'd like to ask everyone is, what is a question you think people are not asking these days and they really should?
That's a really interesting topic. I don't know. I still come back to this point that I think very few people understand how to build and train good retrieval systems. It's like a simple thing, but it just confuses me, like why no one knows how to fine tune really good embedding models. So I'm going to go with that one still. I know at least at Augment, like we found having fine tuned embedding models was really helpful. So as you mentioned, other people say differently, and that makes me wonder, do they know how to train embedding models really well? Yeah, so I'm going to go back to that simple question.
And I bet a lot of it really is the fact that what data do you have access to that allows you to train this embedding model? Like the Cursor team has been deploying this tab model for a year, right? And so what they can train on is going to be much larger volume than, say, a smaller company building out like their coding SDK. I can imagine Codex can probably get a really good code embedding model out pretty quickly, but I don't know if Cloud Code can because they don't really do any indexing right now. So like, how do you go back in time to build out that data set?
Training embedding models on user data is a very useful axis. This is correct.
Yeah, I think that's going to be the big factor, especially because also identifying whether or not the retrieval was good, I think it's going to be very...
Come on in.
Yeah, I think one of the things I just saw recently was like Cursor has their like bug bot, right? Where you make a request, it is on GitHub, there's a pull request, and maybe it's just, okay, retrieval is good, but the pull request gets merged. But that's a ton of infrastructure to have to spin up to try to collect that data. I'm curious, do you agree with that sentiment, or do you think it's actually something else entirely? Maybe it's not just we don't have the data, but really there's something fundamental about training these embedding models.
Wait, so your question is essentially, does retrieval get harder for this? Is it retrieval hard for this new
more like
PR agents?
Have people not trained these embedding models because they don't have the data and they don't have the sort of sensors out in the world, like merged pull requests, to understand what is good retrieval? Or do you think there's something fundamental about like the training of embedding models themselves rather than the data sets that they're coming from?
I just think there aren't that many people that are good at this skill. And so, yeah, I think that's the main reason. And then I think the data is the next thing. With code, there's a lot of data out there that you can wrangle in all different kinds of ways, like from GitHub. and you can do all these transformations on it and stuff. Most domains don't have that. So for code, it's mostly finding great people. I think for other domains, it's probably more the data. But
I'm also I wonder if just that the smartest people want to work in the LLM and not on the embedded.
no, that's actually an issue. That is like definitely an issue, like more like a macro level. I'd say also one interesting point that I was just thinking about when you mentioned BugBot is like some other code search tools that are really useful is maybe I don't want to just search over the code, but I want to search over par git commits. So I basically want to see blames of who edited what lines. Another thing is maybe I want to do like hierarchical retrieval. So asynchronously, not while someone's asking the agent a question. I want to take every file in the code base and write like a one-line summary of it. And I want to take every directory and write like a one-line summary of that. Like these kinds of things can have a huge impact on the performance of retrieval systems. And yeah, I don't know. I just think there's so much to build here. And yeah, it's exciting.
I think you can also imagine giving these systems access to language servers or giving them access to the ability to more naturally browse code rather than just parsing things through strings. Like I imagine like when I debug things, I look at the stack trace, I look at the files, then I traverse through functions. And maybe that traversal is one way of doing it. And then you just say any sort of straight path to debugging an issue, the embedding should be similar or dissimilar.
Totally. One thing with like language server protocols, which if anyone's not familiar with that is, that's essentially when you're coding in your code base, you make little squigglies under some part of your code that indicates some kind of error. That's this thing called a language server protocol. It's like analyzing your code base at all times and like looking at the code and seeing if it's correct and like attaching links between a function name and like the function definition and so forth. Like these are pretty slow. They sometimes don't work. Like they don't work well in broken code. They sometimes work, but like they don't always work. And before agents, it was a bit of a pain to figure out how to take LSPs with all the like issues and challenges they have and integrate into the code base in a way that into a retrieval system that like works really consistently. But with agents now, I'm just going to look at a very simple picture. It's like you could have an LSP tool, and then if that doesn't work, well, then the agent can just call the like code search tool or can call the bash tool. And so now we can like more easily synthesize like different retrieval tools that have different pros and cons without having to like deal with a bunch of complicated work and fine tuning re-rank curves and stuff like that.
Yeah, I think that's super relevant. What gets me psyched to maybe take a look at this a little bit deeper myself.
Sure. Can I say one more fun retrieval anecdote? So I'm working on like a side project right now, just kind of like a weekend hacking project where I'm like building like what I'm trying to have the world's largest index of songs that you can retrieve over. So if I want to ask any question about music ever, I have this like giant index of music. And I found like with ChatGPT, if I ask it a question, like I'm searching for a song and I want to find a song that's like a mid-90s vibe, female singer, insert other qualities. It's not very good at doing this because it's like, it has access to a web search tool and like web search is like not the right abstraction for doing this kind of search. So what I've done instead is I've taken every one of those songs and I've used an LLM to go do deep research on each song to come up with like a dossier about that song. And also for each song, I have this description. And then now I'm doing search over that. And that works really well. And I thought this was like a really cool example of like just one simple little like asynchronous pre-processing step took a totally not working search system and turned it into something that like works really well.
That makes a lot of sense. You're just creating these like synthetic summarization or summary embedding to use and then embedding in that. Yeah, I'm definitely going to explore a little bit more about this. Yeah, and I think one thing I'll just call out is right after this talk, we have another talk coming up from the VP of Algolia. And he's going to basically talk about like query expansion, summarization, changing different embedding models, and how to learn from feedback. And so I think that'll be a pretty interesting segue into some of the stuff you're talking about.
That's awesome. I'm excited.
As always, we'll send an email with any of the references, study notes, as well as any kind of slides and the GitHub repos. Before we go, Colin, is there anything else you wanted to say? Where can we find you?
Yeah, you can. Well, I'll have you send out my contact info and people can message me.
Perfect. Yeah, I think the feedback is that this has been super dense. People are really excited to even just watch this back and get the slide. And so on behalf of everyone, thank you so much for sharing your expert knowledge. I feel that there's been very few people who've been really talking about this kind of stuff. So this is awesome for me.
All right. Bye.